Prime seating available in the front row. Come up close and see the show. Oh. Well, that's a good point. My aim gets bad the further back you are.
Oh.
Speaking of trouble.
Taxi. Oh, you have to find a new one now.
Yeah.
I didn't know it would be him.
Oh, that's nice.
Okay. We're going to talk about contra bassoons today. Yeah. I can see some bad faces. If you ever have to work on a contra bassoon, the first thing you have to realize is that you need at least 2 workbenches, because the contra will totally consume one of them, and leaving no room for you. Believe me, I work on them every day, so all right, bassoons though. We'll skip the contra bassoons for another day. You'll have to come to the factory for that. And I'll be glad to show you all about contra bassoons there, but not here. All right, there's a lot of things about bassoons because you probably want to know. And the primary reason is that the bassoon is, in the typical repair shop, the bassoon is the least seen and the most different of all the instruments that you'll encounter. And I mean, the obvious first thing that makes a difference, it's made of maple. It's the only instrument you're likely to encounter that is made of maple. You want second place for maple instruments? It'd be contra bassoon. You want third place? You want to try for that? Say what? Not really. You're too unlikely. I know, but how? I'm talking about likelihood. You see, and we haven't made as many of those as heckelphones that exist. So heckelphone comes in third.
The maple, is that rock maple?
Rock maple is, there's no such thing as rock maple. That's just a name that somebody's trying to sell you maple as. They can be divided, maples, there's quite a few species. They can be divided into hard maples and soft maples. So any hard maple would probably be a rock maple. Most common of those would be sugar maple, but black maple is also a hard maple. They work much better. And for that reason, the cost of the wood, the raw wood, is greater on those. The soft maples tend to shred, and when you turn them, so it's not as sought after as a woodworking wood. The irony there is that the cheaper soft maples, the red maple, for instance, produces a better instrument than the harder and better working sugar maple, which we put on only in our cheapest instruments. So there's all sorts of ironies in that. You want the best wood for making a fine bassoon, you pay less. For the wood, for the instrument, it costs more. Yeah, everything's back assets. You can't tell which end is up on a bassoon. You start at the top and you end up with the end of the bottom being higher than the top. All right. Now, the most important thing you can do when a bassoon comes into your shop is to inspect everything. And that's where you're going to find out what kind of work you need to do. And it gives you an opportunity to figure out what you're going to have to do on this instrument to make it work right. And the first thing you look at is the case that it's in. That'll tell you a lot about what you're contending with. This is an instrument that was made available to me for the purposes of this show, because I was too lazy to carry one with me all the way from Indiana. I mean, latches are a little questionable. The latches are even more questionable, and you can't put the instrument in the case without it banging on the other parts of the instrument. At some point, you got to decide that the case needs to be replaced, but it's still there, and this is a grade school, so they don't care. But then you get down to the next thing you look at is how much debris is in the case, because debris gets under pads. Debris is a major source of leaks, and taking a look at the instrument in its case, and you can imagine how much problems you're going to have. And don't try smelling the case because you're likely to smell cat. Especially if the player tends to leave the case open frequently. And you got to watch out for those cases. You think I'm kidding? I figured you'd know better. Cases, cats just love open cases. Okay. But yeah, you get that. Oh, by the way, don't hesitate to have a camera available in your shop. Have you ever thought about that? Have a camera available to take pictures of things that the customer doesn't believe exists until especially when you charge them for fixing it. So don't hesitate to take pictures. It can be helpful at times. And you're going to have to log the instrument into your records. So of course you're going to need to find the serial number. Most of the better instruments will put the number on the bracket. A lot of instruments, who knows where it is? I haven't found it on this instrument yet. But it's on the bill. I haven't really looked at it. No, who knows? It's there's not on the boot cap, but I'm going to take this off in a moment. It was a number 18, which scares me. I wish. It's a bassoon-shaped object of Chinese manufacture emulating another maker. It looks like reminds me of a Vedic bassoon. Although it may also be Molinar, I'm not sure about that. But it makes it a perfect instrument for this kind of a lecture, where you can find all sorts of interesting problems. And since I did this for the previous lecture, I know where some of them are already. The boot is the most interesting place on the instrument to find problems. Because a bassoon has a folded board. You know what is meant by a folded board? This is where the instrument is way too long to be conveniently held, so you fold it back on itself, and the fold occurs at the bottom of the boot joint. So you have a U-tube there. That also makes a good container for all the moisture that is generated while the instrument is being played. And so it's very important for routine maintenance to swab the instrument properly. Which doesn't usually happen. This is a school instrument, and by definition, a school is a hazardous environment, and where the standards of maintenance can be summarized as abuse and neglect. And this one shows neglect. There's two forms of neglect. One of them is neglect in the daily care. The kids haven't been told to make use of it properly, or it hasn't been emphasized sufficiently to them. The other form of neglect is failure to have an instrument like this serviced on a regular basis. And that's your guys' job. But only if the owner lets you. You're stuck. You're in the middle of the system and you can't argue in either direction too easily. But when somebody pays a lot of money for a good instrument, they should be willing to pay a reasonable amount of money to maintain it on a regular basis, and they usually don't. I'm going to be passing this boot around shortly, but there's a whole bunch of things I'm going to point out first. And one of the first things you do is take off that U-tube and inspect the condition of the wood at the beginning of the board. And this is where all sorts of serious problems can occur unseen. All you have to do is leave the U-tube on and you never see that. As repair technicians, always take the U-tube off. That's basic to bassoon repair. And you'll find problems that are causing other problems. This instrument has a swelling at the beginning of the unlined side that if it got much worse than this would absolutely cause tuning problems so an octave way in the instrument's range. And so it's important to check these details. one of the first things you do is pull that U-tube off and where's that? Get out an X-Acto knife and, well, actually digitally inspect it first, and you know that this one has a problem just from that. But then you can stick the point in there and see how soft the wood is. And you can compare that with the opposite side. And then usually the opposite side is in good condition, and you'll know it's better wood. But if the knife point sinks into the wood too far, too fast, then you have at least the beginnings of boot rot. Now you know when you have a serious problem when the point doesn't hit resistance until you hit the metal. And yes, it's that bad sometimes. I mean, literally, you don't hit any resistance. Yes, at that point, it's due for major surgery. And it can be fixed. It is very definitely fixable. It's also a specialty job, and you may stop and pause before you do it yourself, because you may be able to make more money by doing your routine work and leaving something like this to a specialist. It's yeah, send it to him. He knows a way to fix them very nicely, but the average repair shop is totally unprepared for this kind of stuff. There's a lot of things on bassoon body repair that, among other things, needs a long bed lathe. If you don't have a 10-inch swing by 36 inches between centers, it's too small. And the average repair shop doesn't need a lathe that big. So that's one of the defining details for a bassoon specialist. This is a good organization because you will encounter people that can help you with these problems. And learn them, meet them, make use of them, because that's the way you can take care of the specialty problems that get in the way of your everyday problems. Now, let's see what I do. One of the first things, actually, before you take that U-tube off, I'll stick it on there so that there's no confusion about that little detail, is to do a water test. And you want to have the instrument, the boot joint together. You need all the keys on for the occasion. Water test is nice and simple. You're looking at your objective is to blow bubbles. Or actually, your objective is to not blow bubbles. But you need a little tool like this. Plug off the top ends. You put it in a bowl of water, and the water needs to go up above onto the wood. Not much, just onto the wood. And then you close off all of the holes and blow into the system and see where the bubbles come up. There's two levels at which the bubbling can occur. One is at the gasket, just right at this point. That's the nice one, because you can change gaskets easily. The nasty one is when it comes out at the other level, and now you have to reseal the whole system. And what effort you have to go to depends upon how the maker decided to make that system. Some of them are very difficult to seal, and generally speaking, the cheaper instruments. And some of them are very easiest. The easiest to seal of all of them is Fox, because on Fox instruments, the bracket assembly is all one solid piece. And you can remove it as a solid piece and reinstall it and seal it as a solid piece. Most of them, the base plate and the band may be separate, and those are the problem ones. This one actually looks pretty good. In fact, it probably is a one-piece casting, as a guess. Number 18.
If the flange of the bow is actually warped, not completely flat.
The base plate.
Yeah, I've had one like that, and I thought, what did?
Well, get out your hammer.
Yeah.
There's no simple tricks. You just have to figure out a good spot to hit it so that it comes out level. It doesn't have to be perfect. It has to be good enough. There's a lot of things about bassoon where perfect is not correct. And that's, I don't even worry about your question on that one, but you have to worry more about correct on a bassoon than perfect. It's a different idea than you're usually taught, isn't it?
Yeah.
There's a lot of things in that category on the bassoon.
When you replace a gasket, generally you use 16th cork.
Yes.
That's like a standard thickness you would use, because I see some that are thinner, some that are thicker.
The thinner ones are because they've been on there too long, and somebody keeps cranking down on the screws. The thicker ones is because the bassoon player decided that he could fix all the problems of mankind with a thicker gasket. Sometimes they succeed, but usually they don't. 16th is pretty much standard. And I would use whole grain cork, just standard sheet cork, rather than granulated cork. The granulated cork tends to compress, and I'll bet the real thin ones were often granulated cork. And the 16th works best. Put it on there, trim it to get, trim the edges, get the holes. Don't forget to trim the holes for the bore, unless you really have something in it for that feature. And then use some cork grease on the gasket. Put it together. The cork grease will help the gasket last a little bit longer. And that's pretty much what you need for that. However, there are some things you need to watch for, and I'm going to pass these YouTubes around. A couple of dandies that have been, well, one was off of that one. This one has been taken off the base plate, but it shows all sorts of interesting stuff. And you will see dents in it. And basically, some people have used swabs that are rags wrapped around a rod, like on a flute rod, and they get a little bit too energetic. And so it's not unusual to find dents or even penetrations in some cases. One of those has a nice hole right through it. Yeah.
Sorry, Mark, is there a bit long? How thick should your gasket cork be? Or what?
16th inch. 1/16 of an inch.
Okay, sorry.
And if there's a way to abuse things, somebody will find it. Actually, there was a teacher, a professor of bassoon, a very influential one in University of Michigan, that promoted the idea of the push swab type, push rod type things. You'll also see especially if it's an old enough instrument, you'll see a woolly swab, the long swab with a woolly part on the end. Those are horrible. At one point in history, they were useful. But in modern bassoons, they're useless. And worse, they leave a lot of debris behind. When it was useful was when the U-tube was easily removed. And at that point, they work fine from this end. They don't, but the problem is they don't clean out the U-tube. You encourage the use of a pull swab that goes in the large bore, goes through the U-tube and pulled out the small side. And that has a much better probability of reasonable success. But it's a school. Schools don't teach anything.
That's wrong.
The way they are. What's the primary purpose of a school band? Play at the football game. Sorry about that.
But in Australia, they don't play the football game, so they don't have a primary purpose. That's why they don't get attention.
Speech day, I think, is the directive that I get.
Speech day, right?
It's speech day.
Okay, well, as long as they have some use at least once a year.
Obviously, New Zealand doesn't have football, but I found the basic education system in New Zealand teaches less than the ones in America as far as the maintenance of huge.
Yeah. Let's not get carried away on education systems. We could ruin the rest of the day.
So Chet, if I find the wood has got rot in it, I won't do it, that's it. I'll send it to someone else. But once if the large bore has got mould in it, have you got ways of cleaning the mould out?
Just a stiff brush.
Yep.
There's not much else you can do. You don't really want to put too strong a chemical in there because that's going to destroy the bassoon. So it's just a matter of cleaning it out. And I don't have a better solution for that. There may be one, but I don't know it. But yeah, there's all sorts of potential for anything inside a boot joint. So the other joints, you don't have that much problem. But the boot joint just loves problems. Yeah.
And, I know it's probably complicated, but how do you treat rot in the boot joint?
I'm going to defer that for a little while, but I do want to get back to it.
Yeah.
Because there's some very nice tricks for doing that are worth sharing and are very low tech. I do want to get to that. Okay. Watch the line bores. The bore linings have a character in hard rubber lining where there's actually a crust that is created when the lining is originally made. And the lining is not made in place in the instrument, not in hard rubber linings. There's ways of casting liners, and if you want to know about casting liners, he's the guy to go to. But But there's a lot of, the highest end bassoons typically have glued-in liners, where you initially mold a hard rubber liner, and it has to be hardened to the right diameter, and it is machined very carefully to get the correct wall thickness, which is critical in the performance. And then it is fitted very carefully into the bore so that there's no gaps anywhere between the liner and the wood, and is glued in place. But while the liner was originally being created, there's this crust that forms on the bore, and it's important for the quality of the sound of the instrument. So you don't casually do something that is going to destroy that surface. Avoid it at all costs. There are times when you have no choice. For instance, if you were replacing a wing tenon, you're replacing a wing tenon, and where the old and new meet, you've got to have a good continuity. You're going to have to ream it and sand it and polish it up. You don't have any choice there. But in general, don't do anything that will scratch the bore surface. Everybody should have one. Have more fun than that, too. The unlined side, you just want to make sure, well, once you get past the very end, you just want to make sure everything is reasonably smooth and clean. And let's see. Yeah, now, this particular case does not include one of those woolly swabs. If it did, I would expect some fur lining inside. Yeah, you've seen that, huh? Yeah. Now, what you're going to see when you take a look at this particular one is fissuring. This is where the wood has repeatedly been wetted and dried and never swabbed out. And it creates open cracks. And those have to be filled and restored to the right dimension. And there's a nice simple trick that we will get on. I'll tell you about that a little bit later. Boot rot can also be completely eliminated by replacing that section, much in the same manner as replacing a tenon on an instrument. And once again, this is a specialty area, so you have to decide whether you really want to spend the time and effort of learning how to do that. And it's very much like replacing a tenon, but it's in a different place. Okay. Couple of other things that you want to check on. Do a magnehelic test of the instrument, and when you do that on a boot joint, consider it not only one joint but two joints. So you got 3 joints to measure. Each side needs to be measured separately as well as the whole entity. Also, if you can do it, check the. Oh, no, it's a manual. Check the pinholes that go through the joint, either 3 or 4 of them, and you ought to see the wing. You will. It's beyond manual mode. But yeah, check the pinholes because they can leak as well. And how you fix the pinholes depends about how much time you have available. If you're doing something where the instrument's going to be around for a week or two, you can use a penetrating varnish to get into there and seal the wood deeply. If you're trying to get it out today, super glue. But if you use super glue after it dries sufficiently, be sure you make sure the hole is fully open and there's not a rough surface of super glue on the sides to make the pin bind up in there, which it will do. Let's see. Oh, brass socket liners. Well, brass or nickel silver. This one happens to be nickel silver on this instrument. Most often they'll be brass, but sometimes they will come loose. And when they come loose, they probably will make it to your shop on the end of the wing joint. That's the better ones. The worst case is when it has come loose repeatedly and has risen up just a few millimeters and bent over. And those are a project to fix. Now, I've got several different PDFs on the NAPRD site for this meeting, and there's the longest one is on bassoon body repair. And you're going to get a lot of information for that kind of obscure fix out of that article. It'll be interesting reading. Once again, if you're not a specialty house, you've got to question whether you should do it or you should make money doing what you regularly do. But there's ways to fix almost anything. Another serious problem on this instrument is that this large socket tends to get splits. This is very thin wood right here, and if it becomes unsupported, and you'll see that on this one, then it's vulnerable to splitting there. The result is that when you put the bass joint in that hole, it opens up that split, which now functions as a ventilating duct. No better to describe it. And you have to remove the band to fix that and fix the tenon. There's no way you're not going to try to squeeze epoxy into that, because it's like trying to glue the tips of your fingernails together. There's just not enough surface. You've got to have a broad. What do I do now?
Oh,
Okay.
We're gonna have an experiment like that.
Can I watch? Yeah, there's just not enough material in there to fix directly, so you have to fix it indirectly. You pull the band off and then bond a layer of fabric onto the tenon, and that will reinforce it and seal it. It'll also add enough thickness so that now you can refit the band snugly. When you see the end of this joint, you'll see that it is not snug. You can drive a truck through there. But yeah, getting that split fix is very important. One of the most common problems that you encounter is when your customer comes in and says, "I'm having response problems in the low range." And of course, that means that everything above the low range is leaking. Maybe the low range too. But yeah, it's ignorance of fundamental acoustics, which musicians don't need to know acoustics. So they don't. But yeah, that's a neat trick. You use a old bed sheet is excellent, and you use super glue liberally. Be sure you have a fan blowing across your face, and because among other things, super glue reacts with the liquid to set, and your eyeballs are rather fluid, and they burn. So be sure you have a fan when you're using super glue in any quantity. But you also want to have several strips of newspaper, nice long strips, because what you're going to do is to stroke down the fabric while it's all still wet, and you will saturate strips of newspaper very quickly, and you just throw them away and get another one, and that's a simple way. And you'll be much happier if you have too many strips at hand than too few. But that will secure that tenon very nicely. This can also occur on the bell tenon under the band there, and the same trick holds true. It's not as critical, or to put it another way, this split is insidious. Whereas the one on the bell, it's okay. You're not, a leak there is not gonna cause any great trouble, but you can, by fixing the splits, the bell will last longer. Because the next step is harder to fix.
Is there a reason why you use a super glue and not epoxy or something like that?
Because I want to harden the whole mess in there, and the epoxy doesn't succeed as well in my opinion, and also it's a bit faster. Although you do want to give it plenty of time to dry, more than you think it needs. I've always done it with the super glue, and epoxy is, I'm not as happy working with epoxy at all. There's places where I definitely use it, but in general, it's not my first choice of adhesives.
Fair enough.
Now, you may have a different opinion, go with it. Everybody has a reason for what they're used to, and it's a good enough reason. Until you grow better.
How easy it is to get the band outside?
Oh, that's variable. That's quite variable. The first thing you do is remove the neck strap ring and any posts that may be in there. Be very careful. Sometimes those posts are soldered on, and it's very embarrassing to unscrew one of those.
Try about the solder of the silver.
The silver solder, it doesn't go through the band, though, does it?
It doesn't go.
Yeah.
It's just a
So don't unscrew the Schreiber post. But yeah, I think I succeeded unscrewing one once using it. And this next strap ring looks like, well, actually it's epoxy. That's a different story, but it would have to come out in order to pull the band off. After that, it's a matter of how tightly it's secured to the wood. And this one looks like it shouldn't be too much trouble. But they surprise you. And sometimes you really can't get it off. If you have one that is really ultimately tight, there's a method, but I don't recommend it unless you're going to be replating the thing. Because what you do is solder some pieces of metal on the sides, soft solder them on, and then you use a gear puller. And be sure to put a plate on the top of the joint and push against it, and it'll pull it right off. But that's an extreme situation, and I haven't had to do that for many years. But there's a way to get anything off. You just don't want to do it too often. Yeah, oh, when boots are dropped, there is a high probability that they will land right on that corner. I don't know why, but that's the favorite place for boots to bang. And so it's not uncommon to see them distorted there. I don't know why it picks that spot, but 9 times out of 10, that's where they bounce. Oh, okay. Let me pass this around. Stick your finger in there, and you'll feel the fissuring in the wood. And a little later, I'll tell you how to fix that. And be sure, both ends are the interesting thing. Okay. Wing has its own set of problems. Actually, you're going to want to check the bore. This one has a lot of dust in it, debris, but it can mostly be cleaned out with a bore brush. You will see all sorts of lines around the periphery, which shouldn't be there. So somebody's done something in there, or it's just not that good a job of creating the thing to begin with. Hard to say which it is. Always check got a loose one here. The tenon cap. It should be secure. And if it isn't secure, it will need to be secured. And the best way to do that is in a lathe with a mandrel in the bore and spin and you have to remove all of the tenon wrappings or cork. And you spin the skirt so to stretch it tighter. That's the best way. It's not always the practical way. But when you have a loose tenon cap, moisture can get under that cap and get to the end grain of the wood, and then you are creating a problem that is much more difficult to fix. It can be fixed, but
So what tool would you use to speed that code?
there's a variety of ways. And Maurice has a piece with a ball bearing on the end that moves it. I don't get that fancy at home, although at work we have something like what Maurice does. I just use a tool that has been ground and polished so that there's no edges. Any edges, you're going to tear the material. And you can just go in there, feel it on the compound by hand, and push the metal where you want it. And basically, you're going to start from the end and stretch the surface, and then dip in for the edge of the cork groove and spread it, push it back further into. There's actually usually a groove in the wood that you can push the skirt into. Once again, you take a good look at the whole instrument, a whole joint at a time, and see where it has problems. It would take a blind man could find the problems on this one very quickly. Take a look. And this one's this way. This one is this way. It has not had a sweet life, and things are not moving because things are crooked. Another thing you watch out for, you've got very long hinges, very long levers with very short hinges. Make sure that they're reasonably stable. Otherwise your pad never lands in the same place twice. This particular instrument happens to have leather pads in these vent holes. I would discourage that. Synthetic pads in these positions are far superior. What happens, well, you can hear it. You can hear all that noise. And basically what you have is a situation where oxides develop on the surface of the metal that bond to the leather. And eventually you can pull the center of the pad right out. And the felt just never works as good. But the synthetic pads are really the correct thing in these places, and for these vents at the top, and also the IG ring key on the boot. This one is a different matter. This one I would use a leather pad in the C sharp.
How about cork pads on the top keys?
I don't like cork, not for this purpose. Belongs in oboes. Basically, you have a different set of problems than exist on an oboe. Among others, that lateral movement that I was describing, that means that you land on the cork in a different place every time you feel like using the key. And that creates an oval facing, which none of it works properly. And there's quite a strong spring system in here. And you're going to create cracking in the brittle cork as it ages. So it just doesn't work as well. Synthetics is really the ideal thing for this place. Yeah.
Would you put a synthetic pad in a whisper key?
I wouldn't, but there's no reason not to. You want something, the advantage to the leather pad is it's not a precise surface. Synthetic pads are more likely to have a precise dimension on that surface, and you want a little bit of freedom to work with on that pad. The other pads are different stories, and we'll get to them later. But in that one place, I probably would stick with a leather pad.
So with the synthetic pads, would you go with more of a softer one, more like the greenbacks, or would you go for a harder synthetic pad?
To tell you the truth, I don't care that much. I don't want it to, I want a little bit of impression available, but not much. I just want a good surface that will work with the vent liner nicely. And that takes a little bit of softness. You wouldn't want a rock hard thing, but neither would you want something as soft as a leather pad, which when you take a look at this wing joint, you can see it's got a substantial depression in the middle, which on these holes you don't want. We'll get into that on other holes later, but in this situation, this isn't. It's not so desirable. Well, I might as well show you this because it's good act. One of the worst pieces of damage that can occur to a wing joint, other than being cut in half, is. Hey, it's fun. Everybody should be so lucky as to work in a factory where you got all sorts of things you can cut in half. But at any rate, one of the worst things that can happen is called liner separation. And that's where the liner loses the bond to the wood. And usually it's because of an external influence, namely moisture in most cases. And you end up with an instrument that is horrible to play on. And in fact, the primary diagnosis is made by playing on the instrument and recognizing by how it plays, and it's no good. Sometimes they can be relined. This is a good example because you can see the discoloration of the wood adjacent to the liner that has been caused by moisture. And on the other side, you can see the discoloration on this side. The discoloration in this case is because the stain that we use to color the wood is a water-soluble dye. And moisture comes in from underneath and sucks all the color out. Yeah, so you're going to see a worst case situation there, which makes it a perfect candidate for the bandsaw. Oh, bandsaws fix anything. Very permanent to fix.
And fire.
That's very rare, and it's unlikely that you'll ever encounter it, but it's interesting to see it when you got an example available to look at. Basses and bells.
Can I just ask a question about that? Do products like Everdura solve
Everdura?
Everdura, it's
Not familiar with that.
it's a product they use in Melbourne where they've got rock there, and
Oh.
Everdura soaks right through the timber and then goes on.
What you would have to do would be to remove the existing liner, rebuild with that kind of a material, rebuild the wood inside, and then install a new liner. You cannot remove a liner and reinstall the liner. It ain't going to happen. You destroy the liner in the process of removing it. So this is the first thing problem that you have is that what you're describing is a factory job. I don't know of any repairman that is set up for doing liner work. It's just beyond the situation that most repairmen would want to get into.
You mentioned varnish before, wood penetrating varnish. What kind, is there a particular make or anything like that? Is it marine grade or just normal varnish?
Oh, there's a lot of varnishes that are thinned or begin thin that will harden up. They usually are not you may have to wait a few days to get and do several applications with them. One varnish that I use is just common hardware store oil varnish and Watco Danish oil. And I'll mix that 2 parts of the Watco to 1 part of the oil. And that penetrates very nicely.
Was that 2 parts water to 1 part water?
2 parts of the Watco to 1 part of the oil varnish.
One trick that I use to extend the life of Danish oil is to fill the bottle once you used it with just gas out of the blowtorch. Pushes all the air out, so it lasts way longer than usual. I got that idea from chemicals for photo developing back in the days.
Varnishes, oil varnishes all dry by reaction with oxygen. And so if you can keep the oxygen out of the can, it'll last longer. And that's an interesting one I've never heard of before.
The LPG is heavier, or whatever, butane is heavier, pushes the air out.
Paraffin is heavier. I think butane you might have a little trouble with. Paraffin is heavier than air.
Do you smoke?
That's a paraffin. Yeah, propane.
Propane or butane, either or, whatever is
Yeah.
in the opportunity.
And you have you use the raw tung oil,
Yeah.
which would work also.
Yes, yeah, helps a lot.
Or you can just put marbles in the can.
Yeah.
Fill up the can.
True.
The whole object is to keep the oxygen out of the can. And whenever I open a new can, I always mark the date on the lid so that I know how long I've been screwing around with that can. And I give up after a while. It's just simpler to, you begin to notice it's thickening and it's time to open a new can. Let's see where oh, bases, bells. Go ahead and have fun with that. The thing about bases and bells to look for is the tenons. They are quite vulnerable to having a lot of stress on them. And in fact, one thing you might want to try sometime is to take a bass and bell and assemble it and hold it by the tenon out at an angle like it would be held while you're playing on it. And you will be terrified by the amount of stress that you're applying. This tenon is the most fragile part on the instrument in terms of splitting. Bassoons do not split the same way oboes and clarinets do, or grenadilla. Grenadilla splits just because it feels like it. And it will split anywhere in the body. Maple will split at the ends because of stresses. It's the same on that socket stress on the boot joint, just as it is on the tenon here. And both tenons are vulnerable. This one's the most vulnerable on the instrument. And if you compare the thickness of what you're at the end of the tenon to a clarinet tenon, for instance, you'll find that this is very thick. So always watch out for this tenon. And in this case, there are several splits in it. And restoring that tenon is not an uncommon job. There it is. When you get into tenon repair, most of the tools that you can buy, like the Farise tool, produces cylindrical tenon or counterbore. Forget it. You don't want that. You set it up in a lathe and cut a tapered tenon. Now this is you have to have it loose. This is too loose because I've played with it too many times. But it's if you get it to fit too nicely, as soon as you apply adhesive to that, the moisture in the adhesive gets soaked up by the wood. It swells a lot faster than you think it's going to swell, and you can get it halfway in there and it stops. This is the same task, except this has a cylindrical socket, and I can fit that in nice and firmly, and have less trouble gluing it together. And it lines up correctly. It lines up beautifully, and then you can plane that out. And we haven't talked about or planing, but we're going to in a moment. And another trick. Take a look at that, and before you turn it around. Do you see the seam on the end or anywhere on the thing? Look at the very end of the tenon. Do you see the seam? Yes. Hard to find though, isn't it? It's right on the inside edge. And that's done again by turning the piece at a taper with a matching taper and a new piece of wood, gluing that together. It fits nice and firmly. You return the tenon to the dimensions. Oil the wood, and the point where it mates disappears at the end, and at this part, you're going to cover it with something else anyway. Who cares? And you can get a beautiful fix that play. When I first did this one, I used to do a demonstration where I would take the pieces and dip them in water and put it together, and just the water would tighten it up so you couldn't remove it. but you can only do that so many times before it gets too sloppy to demonstrate. But yeah, it'll come out in an hour or two, but for a while it's stuck there. And that's what the adhesives will do for you, when you use a cylindrical counterboard. Oh, minor splits. When you have splits like occur in this, although fewer of them preferably, you can usually get some super glue to go in there. One trick is that you go in with a tool and just kind of bend up on the edge, and something thicker than a pen, and it'll help get the super glue into the splits, and that's often sufficient. But the edges of the splits have to line up perfectly. If they're not lining up perfectly, you don't want to do this. Then you have to go into that restoration trick. And but you can do this very quickly and easily. It's not something you want to waste time charging for, because you did it so quickly and easily. But it's worth trying. The next step is the tenon restoration.
Yeah. When you turn the tenon down, I mean, because it's split, do you secure that somehow in the lathe when you turn it?
Yeah, I would. I would start by actually wrapping cotton kite thread, something like that, around there, and saturating it with super glue, which is not a problem because you're going to turn it all off. But that also glues up any splits and makes it more secure to turn. And you don't get aggressive. Aggressive is the way is the next step toward replacing the whole tenon. Okay, vocals. Interesting subject. Vocals are incredibly sensitive little things. And there is almost nothing you can do that won't change the way it plays. And I mean that very literally. The exception is probably replacing the cork. So when it comes in there and has dents in it, you have to question whether or not you want to bother taking out those kinks and dents. And if it's a school instrument, the vocal is not a valuable vocal, let them live with the dents. It's not going to change anything to take the dents out. And you may change more by trying to take them out. A high-end vocal, when you encounter somebody with a high-end vocal, this is their sacred vocal that's feeding their family, so you take good care of it. You're probably better off finding somebody who actually specializes in vocal repair and letting them take care of it. There aren't too many people like that around. Jim, do you do that much?
Yeah, I do some.
Yeah. There's only one guy in North America that I ever recommend anybody send vocals to, and I've seen him do some amazing work. But you send fragments and you come back with a brand new vocal that performs great. I mean, it's pretty good. Name's Marvin Kranz. He's in St. Louis.
He actually replaces them and takes an identical one. Is that what he does?
No, he puts it back together.
Yeah.
It's quite amazing when I've seen pictures of what he starts with, and I know of the vocal, and it plays great.
What was his name?
Marvin Kranz, Kranz. If you ever need to contact him, don't hesitate to write me. And get I'll be glad to refer you to him.
Can I ask a question? Is there anyone in this room doing tenon replacement of bassoons at the moment?
It's a good question. You probably do some, don't you? A tenon replacement?
I did I did a few times, but about New Zealand, you know.
And your lathe isn't really long enough.
It's long enough, I think.
Yeah, I would find your lathe too short. Because when I counterboard, I have to move the carriage outboard of the tenon. So you have the full length of the joint. I'm getting the.
It's tricky.
Yeah.
It's tricky, but it can be. I mean, I have ways around that.
I would do them if I had the bassoons to do. Games, you don't get bassoons to do.
Do you have a lathe on the range of about 10 by 36?
Pretty good.
Yeah, that's what I consider about minimum for bassoon tenon repair. Yeah, there's probably somebody else around that is set up for doing it, but they're few and far between. But there's not too many things that can't be fixed. And tenons is certainly something that can be fixed. Here's another trick. If you ever try doing that, yeah, this is the worst position. When you create the counterbore for a new tenon, don't go through the facing, because when you get into that facing, it's going to rip up the tone hole. If you want to do that, there's ways of preparing for that by eliminating the tone hole, and you'll have to recreate it later. But the value for doing a long counterbore is if there's big splits in the joint. Does anybody do violin repair? Yes, anybody do some violin repair? Now, if you had a split in one of the plates, what you would do is remove the plate, thin the inside, and bond in new wood, isn't it about right? So basically, you're putting wood across the split. And that's what a tenon would do in this situation, a long counterbore tenon replacement. So it's unlikely that you'll encounter that anymore. There'll be only a very small fraction of the number of replacements that you ever see. But it's something to keep in mind. But it takes a lot of extra work to accommodate that tonal. Let's see. Got the full holes. Let's see. Got that. Okay. Now you wanted to know how we're going to fix this boot problem, and it's not real difficult. This is a low-tech fix. Basically, what you're going to do, it can be done without removing the U2 bracket, but it's better if you can remove the U2 bracket. Then you can get to more of the soft wood, especially at the end grain. But what you're going to do is saturate get the right hole. Saturate the area with very thin super glue. And if you can also add a little bit of maple sanding dust. Not sawdust, but sanding dust. And that can fill in those pieces. Go ahead and fill it up too much. You're not going to hurt anything by doing that, because the next step will take care of it all completely. How many of you ever encountered the use of a planing bar for this kind of situation? Ever heard of it? It's basically just a piece of drill rod, 5/8 inch diameter, full length, because you need the full length if you're ever doing tenons here. What you're going to do is take that bar and face off the one end, and so that you can leave a sharp edge there with no burrs. And you're going to clamp the far end, the dull end, in your vise, and you're going to take that joint with the part that you're working on being last, and you just put it onto that bar, and then start sliding, so that you're cutting that area that you've created a excess wall thickness. This, if you have an instrument that has an extreme case of bore swelling, but doesn't justify a full surgery, this works great. You can clean that part out, and it will correct tuning problems. The typical tuning problem is that the E in the wing joint goes dead flat. And the bassoon players, being bassoon players, they will find all sorts of things that they can do to their reeds to fix the problem. But you can fix it much easier right here. And you end up with a very nice bore. What's happening is that the main length of the bore is guiding that bar, and you're just planing out what is raised up above that area. It'll actually get a better surface finish than the rest of the joint, so you end up sanding the whole length of that joint so that it looks uniform. That's the kind of thing that makes you a wonder person to that bassoon player whose reeds have just not worked. And it's a neat little trick. And anywhere that something is in the bore, that will work. For instance, if you got post blisters in the bass joint, which is not uncommon, where you can see little blisters in the bore, it's not really worth the effort, but you can plane those right off with the planing bar. It's very useful after you put in a new tenon, and after you put that in there, there should be a very small ridge where the new piece is it's smaller diameter than the bore. The less, the better, but you want it there. And then you put it on that planing bar, and you can continue that bore completely down.
What diameter is the drill rod that you're using for that?
5/8 of an inch, about 16 millimeters. It's a very convenient size because a lot of my tooling on my lathe I have set up for 5/8 inch collet. It's everything. I think 5/8 for all sorts of things.
Do you heat treat it with a sharp edge?
No.
Doesn't matter.
No, I don't worry about that. It works fine without any special treatment.
Where do you buy it?
Just drill rods, anywhere you.
They don't sell drill rod in Australia.
Yes, they do. You just need to get to an industrial supplier. Let me put it this way. There are factories that manufacture products out of steel and use drill rod in the process of manufacturing, and they have it. You don't have to worry about 5/8. 16 millimeters is just almost identical. It's 4/1000ths of an inch difference. But yeah, I would be amazed if you can't get drill rod in Australia.
Well, I've asked around and a little bit if I'm crazy.
But, I mean, drill rod in Australia is just mild steel, isn't it? That's what we're talking.
Is it
No?
tool steel?
Yeah, it's a tool steel.
Tool steel.
Yeah, it's one more carbon in it.
Yeah.
Yeah. You have sources?
I mean, I'm sure my metal place down the road would have it.
Yeah.
Sorry, what's that?
Like Metal Land, I mean, any of the metal places will have it, I'm sure.
No.
No?
Like I've asked for aircraft drills. You can buy a 1/8 drill
Yeah.
that's that long. And there is nobody in Australia who wants it's you're a bloody fool.
You mean gun drills or you mean long?
They call them aircraft drills.
Wow, I could buy them in Auckland.
Sorry?
I could buy them in Auckland. Like, it's just long diversion drills.
No. This is a drill, a
Yeah.
1/8
Yeah.
drill.
Yeah.
It's that long.
Yeah.
And a fluter on the end of it.
Drills.
Yeah. 6, 12, 18-inch drills. Yeah.
That's because that's the craft city of the world.
I could get a lot longer.
So it's just a matter of knowing who you buy it off.
Yeah. Yeah, I mean, any city in America would have a supplier of materials like that. And probably several of them competing with each other. So I'd truly be amazed if there are materials, industrial supply sources in Australia.
Contact Boeing.
You see if we have close to time here.
If you want one of those, I'll contact Boeing.
Okay, we're just about out of time, and there's all sorts of things I'd like to cover, but let's jump into pads. Bassoon pads, padding a bassoon is a special problem, because if you compare it to every other woodwind, they're all simple, because you have coaxial tone holes, so that you can actually cut the facing and the tone hole simultaneously. But then you get into a boot joint, Yeah, I cut everything in half. And you forget any ideas of perpendicular. It just doesn't happen on a bassoon. And as a result of that, you end up with a oval aperture for the hole, in which, in a conical or a spheroid surface, and that means that the lengths of the major axes are lower than the sides of the axis. And you don't have a level tone hole, and you don't want to make a level tone hole. You do not want to make a level tone hole. It is easier to pad one that isn't level. Now, most repair technicians will hear me say that and think I'm some kind of a nut. But you have to pad a bassoon. This is not an oboe, this is not a clarinet, this is not a saxophone, it's a bassoon. You have to pad a bassoon. And on a bassoon, it works. What you want to do is make a flexible pad so that the pad can conform to more of the facing. It doesn't have to conform to the whole diameter of the facing, just the part where you're past the lowest point of the tone hole. And a flexible pad does wonders. Don't break it. Yeah. You can do them in a variety of different ways, but the essential tool is a pad die. And basically that holds the shape of the pad while you reconstruct it. You can take a standard pad, open up the back, take away the cardboard, and you don't lose it yet, you'll need it in the pattern. But then you can put other materials that are not so stiff in the back. The trick is you want thin materials. You can have layers of them and they'll still be flexible, but a solid material of the same thickness will be stiff, which is what you're trying to take out of the pad. And then you can reform that pad over the more flexible backing, and you've got a flexible pad. I also stitched the holes, stitched the pads, and because once you have a flexible backing, when you take that stiff flat thing and curve it, there's more leather there than you want. So you hold that leather in place. And why do you need that held in place? Because if you don't put it where you don't control it to be where you want it, it will fall into the tone hole. And then it becomes a plug. And if you think a moment, it takes longer to remove a plug from a hole than to lift a lid off of it. And that's response time. So you want to keep that leather under control by stitching it. And you'll notice when you see the pad die that there's a hole in the middle of it. That has two functions. The obvious one is to poke the pad out of the die. The secondary one is to stitch the pad. So you stitch it while it's in place in the pad die. By the way, the adhesive to glue it together, what I use is Aleene's tacky glue, which should be available in art supplies, craft supplies, and it's flexible when it's dry.
What is it usually used for, the glue? Because it's highly likely that it has a different name here.
Yeah, I would believe that. Everything seems to go that way.
It's a craft glue.
It's a craft glue,
What's
yeah.
it called? Aleene's?
Aleene's, A-L-E-E-N-E''S, Aleene's tacky glue.
Yeah.
There's probably,
I use craft glue.
yeah, I use,
Yeah, if you go to
I
places,
go to a solvent from craft places for cleaning.
I don't know if there's any kind of
It's
solvent
probably-
involved. I certainly don't sell it with the glue. But if you go into some place that caters to the arts and crafts community, you're going to find that or a very similar glue for fabrics and that dries flexible.
Any particular thread you use for stitching?
Use button thread. Beware of getting too thick a thread or too thick of a needle, because you're just making a bigger hole. But there's plenty of tolerance for that even. Because when you finish seating the pad, you're going to seal those holes anyway. But yeah, the real trick is learning how to tie the knot, and it's basically a surgeon's knot. You start the stitch through the back and then turn around and come up back from front to back. And then you have to tie a knot, and basically a surgeon's knot is a square knot that's done on they call it a hemostat, and that way it costs more. I use a pair of very thin tipped pliers for the purpose. And so that you can actually wrap the thread around the pliers and grab the other end and pull it through. And you do that so that you end up with a square knot, and you have a nice secure knot then. And let's see, then after you've got the thing fully seated in place, then you seal it. And I know I'm jumping over a big topic, but let's get to the sealing first anyway. For that you use silicone sealer, just household silicone sealer, and you smear on some onto the leather. And remember, this pad is already in the cup and it's been seated. You smear the silicone sealer on there and wipe off all of the excess. You wipe it clean, and then take some baby powder and dust some of that on there and wipe it, rub it in, and wipe off all the excess powder. And then you'll take a stylus and heat it up and dip it into a cake of paraffin and use that to seal those stitches. You don't want a puddle of paraffin, you just want the stitches sealed, that's all. Now, as for seating the pad, your choice of pad cement is totally up to you. I tend to use George's pad cement, which is a fairly heavy, high temperature pad cement, for no reason more than that's what I'm used to.
Excuse me, sorry, Chief. Just with the sealing of the pad, just say like a Yamaha custom Bassoon. I notice they've got nice pads now with a little bit of sealant on the stitch.
Mm-hmm.
They would have been all sealed like in the factory, wouldn't they, or not?
I'm not going to answer that because I don't know the answer. It's quite possible that your supposition is correct, but I can't confirm
Right.
I'd like to believe
that.
that.
The leak test is the only way, isn't it?
it. Yeah, if you can get any air through the leather, then they haven't sealed it. And the natural leather is porous. Yeah.
I have one question, general question, and probably really simple. Where can I get paraffin wax from?
It's used for canning. So somebody who cans jellies, for instance, will seal it in the jar with a layer of paraffin on the top of the jar. Candle making, yes. Candles making supplies. No, this is a matter of the history of sealing pads. And that's the oldest method. And basically, you would paint the melted paraffin on the pad inside the tone hole. You wouldn't want it to touch the wood. That is the best way. But then along came somebody, actually his name is Dick Rush, who came up with a way of treating the entire pad. This was a liquid carnauba cream, and you treat the whole pad. And we did an interesting experiment at Fox when this first came up for discussion. And basically what we did was to take a pad of Bassoon and get a good test out of it, so we knew where we were starting. And then we sealed the pads with the carnauba cream. We got an excellent result. Then we added the paraffin to it, and we lost. Because as the hot paraffin cools, it distorts the leather. And with this silicone system, everything is done at room temperature. You don't have that kind of a problem. It works quite well. One of the tools that I use for padding are domed pad slicks. And don't ask me where you buy them, because you don't buy them somewhere. You buy ship stock and you make them. It's 15,000 seal ship stock. Yes, you got it. Yeah. Raise the center. Oh, okay. There's all sorts of other stuff that I can bring up. I'm going to encourage you to read the PDF files that are on the website for the show, because there's a lot more information than I can squeeze into an hour or a day. There's a whole section just on bassoon padding. There's a larger section is on body repair, which most of you won't be able to. There's parts of it you'll be able to use, and parts of it that require special tooling or machinery that may be a problem. But it's good reading anyway, and we'll give you some ideas. Oh, one thing I want to include on bassoon padding, be sure to remember that the pad is only part of a system. The other two parts of the system are the pad cup and the pad facing, the tone hole facing. All of them work together. If you want to think about an interesting comparison, think of cereal bowls and service plates. And if you put cereal bowls, they automatically center. Cereal plates don't automatically center too well, do they? They kind of slide around a little bit, but cereal bowls are going to automatically center with each other. And that's what you have with these, the pad cup and the tone hole facing. And between these two conical entities, you now want to stick a flat pad. It's out of place, isn't it? If you had a pad that agreed with the facing and the pad cup, then you've got a system that wants to work together and achieve a common goal. And probably nobody's pointed that out to you. But that's the way the instruments are.
I used to use like a thumb when you put the pad in and kind of just,
Absolutely.
especially on the F, you kind of put.
Yeah, that's your most important tool.
Yeah.
And in fact, it does more than just push around the pad. Feel for lumps. If you use something like George's glue, which comes in beads, you may end up having lumps under there. You want to feel them and get rid of them. Use enough heat to get them to flow out of place. And when all those details are working together, you get a nice result. One of the big advantages that you have with rebuilding your pads is that you can control the pad thickness, and that's absolutely critical. And the most critical place for it is the low E key, the F tone hole here. Because that's probably the most difficult pad on the horn to seat nicely. And if you have a pad that is the perfect thickness, it's real easy. That makes all the difference, is pad thickness right there. Another thing to keep in mind, you have holes where you have facings where you have multiple holes in a facing. Don't forget the right hole. Where you have a larger hole going into the small bore and smaller holes going into the large bore. Same thing down here, which in this case is an oval hole going into the large bore and a tiny hole going into the unlined side. A leak from one bore to the other bore under the pad is a leak. It's just that simple, it's a leak. For that reason, always check your pad, the seal of your padding, each bore separately as well as the entire boot together. Always check that detail very carefully, because you do not want leakage going across. It kills things. It's part of the games. Okay. Let's see. Okay, we're after noon, which is supposed to be the quitting time. So, any final questions? Somebody has an interesting question? Oh, you always have interesting questions.
No.
What you got now?
I was just wondering what you do. I know like horizontal key work is good because it flexes, but do you worry a lot about like vertical key work in terms of pivot screws and wedging and how tight you find that because of moisture and those associated?
This key will always be loose on the bassoon. Not by intent, it just seems to happen. There are things that you can do to tighten it up, but in this case, for instance, you'll notice that the casting is right up against the post. There is no place thinking of swedging it isn't going to happen. There are ways to fix that, but they involve creating inserts. And what you need to do is to make yourself a reamer, just a straight cone reamer. And it's not too critical what the angle is. I would suggest 3 to 5 times, the taper is 3 to 5 times the diameter of it. And just make it right down to a sharp point, and you'll need to cut away, harden it and cut away half of that so that you have actually a cutting reamer. And the diameter of the biggest diameter needs to be bigger than the diameter of the hinge rod. That's very important. You will need some hinge rod stock of the same diameter and type of metal that you're fixing. It doesn't have to be perfect; it just has to be close enough. And what you're going to do, you may need to drill a deeper pilot hole to do this. But now, dream that out so that you get to the full diameter of the rod stock. I mean, right up to the cutting edge. And now you're going to take that hinge rod and you're going to do a couple of things to it. First of all, you need to create a pilot hole right down the center of it, too deep. You'll know what too deep means in a moment. And you're going to take and file in the bench motor until you get a matching taper so that it sticks in that taper that you've created and it's secure. And you've got to make sure you have that pilot hole long enough, or you're going to have trouble later. And you'll still find out what long enough means. Now, you're going to silver solder that into the end of the key. And you cut off a piece of very fine diameter silver solder and put it in there with some flux into the socket that you've created. And hold the piece on there. It's self-straightening because you've got matching tapers. And heat it up until you feel that solder dissolve or liquefy. And then remove it. Now you've got a key that's about way too long, which gives you a great deal of freedom over where you're going to cut it off. And you cut it off more than long enough. And now you've got a piece of metal in there that's the same diameter of the hinge rod with a pinhole in it, a pilot hole that you can use to ream your pivot taper in. And if you put the heat in the right place, you can do this without burning the plating.
Do you find that important as, like,
it depends upon a bunch of
key work on a bassoon?
You can get away with a lot, but there are certain places where remember, a sloppy hinge, there's 2 directions of slop. One is lengthwise. That's the one I don't worry about. What I worry about is what it causes, or what it can cause, and that's lateral slop. That's important. There are places where you have one key picking and rotating another key, and before it rotates the other key, the key lifts up lateral. You don't want that. You want that. You only want radial rotation, not lateral. So that's where fixing those pivot sockets becomes very important. As far as something like a whisper key, end play is not that important. As long as you don't have so much lateral play that it gets noisy. Because, this pad it's got a big target and it's not going to miss. There are other places where you do have to worry about that, but that's low on the list.
Okay.
With the whisper key, setting it up to seal nicely, the correct way, tell me if I'm wrong, the correct way of tuning a bassoon would be using a different vocal, is that right? But some people lift the vocal in and out, the tuning. Mm-hmm. Is there a combination of both, is there?
There are several different factors going on. First of all, in any place where you're sticking a tenon into a socket, you don't bottom out at the bottom of the socket. There should be a gap at the bottom of the socket. You'll find this on trumpet mouthpieces. You'll find it on bassoons fitting it. You don't go all the way to the bottom of the socket. There should be on a bassoon about a 0.5 millimeter gap, roughly, 15 to 20 thousandths of an inch. It's, the amount is not so much critical as its existence. It will play better.
How does that affect bivocal?
It just makes it play better.
Okay.
That's
It
all.
just does. Okay.
That's all. That's enough, isn't it?
Yeah, absolutely.
And so that's part of your answer.
But setting up the whisper key nicely. So it's I get a lot of bassoons that the angle just seems completely wrong.
Yeah. For a variety of reasons. For instance, if you have a vocal and an instrument, one or the other of which was made in East Germany.
Yeah.
You know what I'm laughing at, don't you? Because the button positions on the East German bassoons way back then were in a very awkward position. And they just don't work together. And it's damn near impossible to fix it. Also, you find that sometimes when you got the right match, even then the button won't center squarely on the pad, in the center of the pad. And for that, you change the angle between here and here. You grip across this offset place, and you grip this, and you can change those relative to each other, and the pad just walks back and forth across the button.
Yeah.
And then you end up having to change the rest of the pad, the length of the hinge as well. Yeah.
On Schreiber, we used to set the vocal in a certain position, which was like roughly where the three posts for the A and the high D and C is. And in line with those posts, does Fox have a similar way of like determining like this is usually the position for the vocal?
Oh, well, we mounted with jigs, so that part of that's covered just in that. But basically, with the bass and wing together, you do not want the vocal coming up square from the plate. It's outboard roughly over the high A key.
Yeah, we used that guide to inside posts of the A key and the high D, so roughly over those three posts. That's where we used to set it. So you look down, it's like roughly. Yeah, well,
Got there.
so it would be about the same.
Yeah, very close. It's so close that none of the customers have ever noticed the difference.
I've also noticed with that bassoon there, it hasn't got a chimney in the wing joint.
Oh, this? Yes.
No, on four finger, I think.
Oh, yeah.
Yeah, but the other one, the cutaway one, had three, and they were actually set into the bore quite
Exactly.
heavily.
So the theory is that it's going to keep the fingers dry. The reality is that nobody taught the bassoonist how to hold his bassoon. I'm serious about that. If you hold the bassoon properly, you don't get moisture in the finger holes. What happens, you get a situation where as they're playing the instrument, the finger holes are actually up the side of the bore a little bit. Not much, but enough. But as soon as they pause while they're playing it, the normal habit is to rotate the instrument so that the broadside is against the side, and they sit there counting rests and draining moisture from the bore into the finger holes. If they wanted to avoid that, they'd learn to rotate the instrument the other way so that the vocal goes over their left shoulder and the finger holes stay high and dry. And you never put it across your knees, because at that point, the moisture down here in the U-tube flows into the G-sharp tone hole. This is all basic how to hold your bassoon that never gets taught. Musicians know nothing about their instruments. If you want to find, if a musician actually wants to learn about an instrument, they need to go to repairers and makers. It's their first source of information.
I've heard horrible stories of teachers telling their players to glue the cup on.
Oh yeah.
It's just unbelievable. It was made to take off.
Yeah.
That chimney's interesting because I had to replace the Bakelite one, which had cracked. Oh, it was a horrible job. But I was worried about how deep to put it into the bore. that tube.
Oh, the tubes, yeah.
Yeah,
And,
so,
yeah, and Schreibers especially have a raised hard rubber liner
Yeah.
in this position that fractures and breaks.
yeah.
And as far as extending it into the bore, there's no practical way to measure it. It's done by eye. And you just, if you stick it in too deep, if you stick too many of them, all of them, for instance, you're going to stuff up the horn. So you don't need a lot, but you need enough. And I can't even give you a estimated dimension for it. It's just strictly done by eye.
You don't want to get caught on the pull through either. I suppose it's.
Yeah, you better leave some. Don't leave sharp edges. You know, don't hook things. There's ways of doing that. The way you shape the end of that will make a big difference in how much volume the end of the tube takes up in the bore, and how readily moisture can get past the tube as well. So there's a bunch of little tricks in that, and I've seen some craftsmen who put them in for aftermarket, and they put them in too deeply, and the horn just is stuffy, and you back them off and they're better. But there's no perfect answer to your question. And I would put a metal tube in there simply because it's an exposed liner. It would be more durable than a hard rubber liner.
What's the metal of preference there?
Oh, you can get arguments over that. I would just use nickel silver. But there are some people who know for certain that their instrument cannot perform without sterling silver. It sounds like flute players, doesn't it? Bill's trying to chase us out?
No, don't mind me.
Okay.
No one else does.
Any tricks how to drill out like a broken finger bowl like that?
Actually, if I were doing this myself, as opposed to at the factory, where we would use a tonal machine to drill it out, I would go in with tapered reamers and have a matching taper on the tube. And those fit very nicely. And then you don't have to worry about drilling out the hole. You just make sure you have, there's very little, the bore is so short that you have to have several tapered reamers because you keep banging the far side of the bore, which you don't want to do. But you do want to get it reamed all the way down to the bore, because if you have a oversized cylindrical section adjacent to the bore, moisture gets past the tube at that point, and then you create problems like that rotten wing.
And you use shellac to glue them in?
You can use, with the tapered tubes, you can use all sorts of things. Shellac, beeswax, epoxy, whatever turns you on at the time. The advantage of the beeswax is you can tune the tube. You can very easily warm it up just a little bit and pull it out and file it without getting all the debris inside the bore, and stick it back in. But it's not as secure in the long term as something like epoxy would be.
I'm a big fan of making something that you can actually take out and repair rather than building for eternity.
Yeah, you can get the epoxy ones out too, but you have to heat them up pretty hot.
Yeah, it's typically find that troubles a little, but that's nice with the wax, so I'm all about it.
Is there any rule of thumb setting up the low B, C, D?
There's a couple of them. One of them is that your primary problem is getting the correct pad opening on the low C key, because both the low D key and the low B key depend upon that key. And so you want to get the pad opening set on that, and then there's a little bit of an arch on here, and it could be flatter. The flatter you keep these two touches, the better your access to the high D key. And that's the trick of it. And this is more important than you think. I would recommend that you start by setting up the bass joint, because if you get these correct, then you can set up these. And you do these before you do the two-prong key underneath, which is part of the C-sharp, D-sharp trill key mechanism. And You get that nicely set up, and and for instance, you notice these things are bent way outward like that? They should be a straight line all the way down the center. And somebody has violated that. And terrible to have a violated bassoon. Here's another trick. And when it's set up properly, these posts and these posts, like all of these posts on the bass joint and this post, should be parallel. And that actually happens occasionally. But that's the ideal concept of it. And there's a whole bunch of other little things that are more manufacturing related than that. But when you're trying to figure out whether everything is put in the right position, that rotation of the bass joint and the wing coordinated to it so that everything's parallel, it comes valid.
So you don't want to see that too high to the picture that you have.
Yeah, that's the D tonal. So yeah, exactly how high depends to some extent upon the model of instrument, the design of that instrument. So there's no one perfect. There's some basic rules of thumb that you can go by. I can't remember exactly what size we use, but I think it's like 5/32 opening at the widest point.
Do you have any preference as to cork or lapping for the tunes?
I definitely one or the other. It's a toss-up. The thread wrapping is a little bit more challenging to get done correctly. It takes a little bit more attention, whereas the cork is more or less automatic. Now, some instruments you must use cork. That includes Schreibers, because they're made by a clarinet maker, and clarinets have cylindrical tenons and sockets. And with cylindrical tenons and sockets, you want cork. You don't want to try putting thread wrap on those. The top end bassoon makers, including Buchner and Heckel and Fox, they will have tapered sockets and matching tenons. And with those, you have complete choice. And with those, string works very nicely. You can set it so that it goes almost all the way down into the, leaving maybe a quarter of an inch or so to drive it home with. And it fits very nicely and is secure. You want to make sure that when you've got that string on there, in fact, whatever you put on there, that you can take this thing and there's a little rock. This is a lot of rock. Well, actually, it's moderately a lot of rock, not hugely a lot of rock. And it's nice when the tenon, the color of the bell ring isn't fish belly white. And it's too white for me. Fish belly white. Got a better description?
That's appropriate.
Yeah, when we first started molding bell rings, they were fish belly white. And that was long before I started working there. They'd given up on that color fairly quickly. And it just looked sick. So what have I missed? On contra bassoon, you need 2 workbenches, and actually, what I do is I use a shot cart with an extension on the top, and that carries the contra bassoon cradle, and that's much easier to work around because the contra bassoon will not only steal your entire workbench, but it will hide all of your tools.
That's how you start cleaning.
Doesn't take much experience to prove that.
Oh shit, I can't find my screwdrivers.
That's, if you ever need to contact me, that's where I can be had there. And I always enjoy technical questions. And of course, I'll try to sell you whatever we need to sell you that day.
Like that nice green felt that Fox uses.
It's ultra suede.
Is that what it is?
Yeah. And Jeff will sell you some of that. In fact, he'll even probably provide different thicknesses of it or something, I'm not sure. But, or different colors. But it's just, that's basically something you get at the yard goods fabric store.
Thanks so much.